So to overcome this challenge, uh, this API-led connectivity approach comes into picture. So our whole scope is divided into three main API layer. So first layer is system layer. So it exposes the system's data as an API, which are in private APIs that is not directly exposed to experience API. So it's basically connecting to our endpoint, and which will give the data without touching into actual database. So once we created this small connector, we'll hold the connection with our end system. Then we'll build a business logic out of that, like we need order status and order history. So which comes into process APIs. That means we are processing something that are built on system APIs. That means order status will get order details in order system API, and customers which will give the records from SAP and Salesforce, which we have previously built on system APIs. Then it will expose another layer, which is experience layer, which is the actual endpoints layer, which will fulfill our requirements. That's it has to operation like check order status and check order history. So this is the new approach that MuleSoft is following, that it will connect our end system and consider as a system APIs. Then it will create a process API, which will process some uh, does some transformation, and it will expose as the experience APIs. So in
Can I
our,
just come in there?
yeah.
So, so again, this is MuleSoft's or Mule's approach in building APIs. This is kind of a reference architecture here. Mule says that, hey, when you build APIs, don't just build one layer of APIs, build 3 different layers of APIs and separate them for its function. Again, this is an ideal, it's a very large scale implementation architecture, so that you can really control and govern APIs at various levels, and it's extremely scalable. But this may not be applied in the sense of it in all organizations, in all scenarios. But it's good to understand what reference architecture that Mule is suggesting here, where you have system level APIs, you have process level APIs, and you have the experience APIs, which is what the UI layer would interact with. A typical example or a scenario for a system API is that you have objects in your database. Exposing those CRUD operation is your system APIs, right? So all your insert, update, delete, create kind of scenarios, exposing them as very fine-grained APIs is what a system layer would do. And then at each level, of course, the security is built on top of it. But system API is basically your CRUD operation on objects. Then comes your process APIs, where you define your business processes. Again, as mentioned here, your order-related business processes can have API. Now, when you go to the higher level here, which is now the process API, it will be more coarse-grained API, not fine-grained. It will be coarse-grained APIs. So, so this is more aligned with your business processes or functions that you would require, which may, in turn, handle or deal with multiple fine-grained APIs here. So if you look here in this example, you have customer, which is a process API, is dealing with both SAP customers and Salesforce customers. So you can see that at a process level, it is coarse-grained, not fine-grained anymore, right? And then your experience APIs are how you deal with the You're basically your verbs of those process APIs. So if it's a customer, a get customer or delete customer or get all customer, count, or those verbs in your REST world, however you want to interact with it, whether it's based on Open API standard or a RAML standard. RAML is a Mule standard, right? So however you want to term it, your REST framework and your URL, URI, your resource identifiers are nothing but your experience API. So on top of the process API, now you have a customer process API. Now get customer, delete customer, get all customer, or even post activities are all part of that experience API. That's my understanding. Vishal, Mahesh, please come in if something is not aligned. Again, what I'm saying is my experience, my understanding of technologies. I'm not a Mule expert at all, so please correct me if Mule is positioning it differently. Go ahead.
No, it's as you explain in detail. So it's actually behave like as it is. So we'll just go further. So previously we built only web app API. Now in later onward, suppose we need to create mobile API, then we can use these small APIs which will be built previously, and we can migrate another toll shipment and UPS shipment as another system API's connector. Then with the help of this process API, we can get shipment status process, and that is uh, applicable for mobile API. So
Yeah, you could also see here, I think the other important picture that this is uh, showing here is that all the source system, target system connectivity is dealt by the system APIs,
yeah,
right? So all your orchestration, the business logic is dealt at that layer. And I'm saying business logic may be dealt at the process layer as well. But your source connectivities, where your all your adapters, connectors are
Endpoints,
yeah,
adapters are basically in system APIs layer, and then like what we design, like we orchestrate those orchestrations or those processes or those workflows basically comes under process APIs, and then what we expose like an API, so that comes under experience API.
yeah, correct.
yeah. Again, this is a reference architecture. It's in an ideal world we can follow this strictly in a large implementation in a very structured organization. Yes, it makes sense. But when you want to implement in a small organization, you try to combine.
Yeah.
You are not really short circuiting anything, but you're only trying to optimize it in a way that it doesn't have to look that complicated. You might combine or fold certain things into a consolidated form. Yeah.
Okay. So it enables and empower the entire organization that centralized team is in system API layer, which unlocks the assets and decentralized access. It will provide the access to LOBIT team, which will discover, reuse assets and compose information. That means if we are getting the information from SAP and Salesforce as a customer, and e-commerce will give the details about order. So with the help of this LOB team, they can reuse the assets that we have previously created, and then the experience layer is like actual developer work. That means it will discover the process APIs, then it will be accessible to end user. That means it will consume our APIs that we have built with these three layers. Then it will give the more picture about that how this API-led connectivity will improve our application network. Then it will deliver on time and within budget. Then it will drive reuse of components. Then it builds on governance, compliance, and security and scalability. It actually meets the need of your business that we are actually looking for, and that where we build as artifacts which can be reusable. Then
Could you, Mahesh, could you
yeah,
go back to the, no, the previous slide? Yeah. So just to give you a little bit more understanding on this, if you see here, in each of those layers, right from your system APIs to the experience APIs, there is proper control and governance. So if you see the first level, the unlocking of assets and provisioning for who should access the API and where it should be visible, things like that are controlled at the system API level. Why is this important? Because IT primarily deals with this layer, and IT is responsible of the underlying asset and its access. An asset here is data, right?
Data. Mm-hmm.
So IT has a primary control. They decide who will get what access to data, whether it's a read, write, or full access. So they have the control. At the same time, IT is not locking it down or trying to do everything here. IT is saying, hey, whatever we are building, we are exposing it to you guys. How are they exposing? This is where the API portal or a visible interface is available for the line of business, which is the next layer here, right? So the line of business has got the available APIs. Now, if you see here, the line of business also says IT, whereas the other one also says IT, the central IT. The difference here, again, this is a reference architecture, right? There are organizations where they have a core IT team for the entire organization, more like an infrastructure team.
Mm-hmm.
yeah, it's cross-functional team.
Yeah, and then they do have IT departments at each business unit. So both of them are IT primarily. So for example, I'll give you an example here. The SAP system, which is one of the backend systems, or let's say any other system, any ERPs or any databases are centrally managed for all good reason, because of high availability, because of scalability and infrastructure management. They are managed by centralized IT. And the architecture team and the core IT infrastructure is still central, which is common for the organization. Typically, it's a shared department or a shared resource. And then each of the business unit may have a different extension of those systems. For example, one line of business will have a Salesforce system for them. The other line of business may not have Salesforce. They may have Cognos, for that matter. And the third line of business could not have any of this. They may have Excel sheets running their business. So those are line of business completely discrete and different. They don't talk to each other. They're running as a separate business unit, almost like a separate company, right? But they all have to, because of the common group that they're working with, they all have to use the same core system, same infrastructure, and leverage the same data that's underlying that is under these core systems. So in such a scenario is where you have this central IT, which is their infrastructure team. Infrastructure doesn't mean hardware alone; it could be even software related infrastructure. And then you have line of business IT, which is again an IT team, but then they will work on what is exposed from the central IT, because central IT is more responsible for their core assets or core data. So they would say that, hey, UPS, I'm looking at this screen, UPS related information, I want to expose to only one business unit because they are dealing with UPS. The other business unit does not deal with UPS. So when I expose the system APIs, I will give in a way that only this line of business IT has access to it. So the portal, which I think later at some point in time we will see those portal. Every tool has kind of a discover portal where they will see what APIs are exposed. It's basically like a registry, right? In
Yep.
the older IBM term, they had a product called WSSR, or something, Web Services Registry. That was one of the API products that they had. It is now, I think, it's decommissioned, or at least on the way for decommissioning. So similar to that, it's like a registry. So this is more web driven. So in a portal, once you log into the portal, they will see what assets are exposed to them and what privilege they have on it. Then they can subscribe to that. They can subscribe to a plan and things like that. So that's how the line of business IT. That's again an IT department, most likely an IT department, right? Using that system APIs and building now the process APIs. Now, keep in mind that these line of business, which is in the middle layer here, can use a completely different middleware. So which means that the system APIs are exposed using, let's say, Mule, but then the line of business will say, oh, I want to use cast iron here, or I want to use Jitterbit here. So they would use Jitterbit to consume those APIs and build the orchestration layer or process layer for their own end systems. And then you have the experience level APIs, which is what guys who are building UIs or guys who are building application, let's say mobile application or a web application or a backend application, they will say those developers are again line of business team, web developers or application developers. They will use the exposure and the orchestration layer or the process APIs that the line of business has built. So do you see how these three layers are interacting with each other, and how the information flow is happening in an API world? Again, this is all part how in an API world, or what we call as an API economy, right? The earlier term what we used in the industry was API management. So this is nothing but an API management or an API economy. I think that is more of a term that is more commonly used. I don't know what definition it has. Mahesh, can you pull up Google and see what API economy means? But I see this as an API economy, where you have an entire economy built. What is economy? You need to understand what economy is first. We talk about economy in a business world, right? In a finance world. So what does it say? API economy is an exposure of an organization's digital assets or digital services and assets through application programming interface or APIs in a controlled way. I think that's the most important thing. It's in the most controlled way, where every layer, every segment has got governance and security over it. So in this context, the word economy refers to the careful management of available resources, and the term API economy can also be used. Oh yeah, that's what I just mentioned, right? So I almost wrote the statement. Okay. So hope you guys are understanding it better now. I have no intention to take over this from you, Mahesh, but I thought certain things are important to
Mhm.
mention. Yeah, go ahead.
So C4E organizing differently to drive API-led connectivity. So again, it's a cross-functional team uh, which has central IT, a line of business IT team, and innovation team, which will ensure that assets are productized and published, consumable, and consumed broadly and fully leveraged. So this is the for improving our APIs, that what needs to be done at our API layer, and this team will guide us to improve our APIs, and it will discoverable more. Then success of C4E measures on asset consumption, that our asset, how many hits are given to that API, and with the help of that feedback, we can leverage this and we can tune this API as more productive. So this is the application landscape that which has endpoint systems. Then every project adds value to our application network, that we are only dealing with SAP and Salesforce. Then this API-led connectivity adds application networks to those endpoints, and later if we integrate another application like NetSuite, then this endpoint is added to our application network. Then we can use that as a system APIs to connect NetSuite database. So here you can see that C4E serves assets on application network, and these are the small APIs we are exposed in process APIs, and which can be used for any developer to consume that API and get the response. Then application network emerges bottoms up via self-service. It provides visibility, security, and governability at every API node, because it's connected to actual endpoint with the system API layer. Then it will cover business logic into process APIs. Then it's reconcilable and built for change. Then, as all of you know aware of what is APIs and what are the types of APIs, then we can skip this part. So it's actually demonstrating the actual types of APIs and how,
Mahesh,
yeah.
Mahesh, can you go back to one slide? I just want the team to be aware of. I don't think it's wise to skip it,
Mhm.
but there are different levels of people here, and
Okay.
I'm all for even the most newest person to learn,
Mm-hmm.
and the most experienced person here will wait and listen, right? Even though they know these. So if you go back to no, not what exactly is an API. Just go one. I just saw one slide. Yes. Oh yeah, here. No, not even. Yeah, I think that's the one. That's the one.
I think this one, which
Yeah,
has three
yeah.
types.
Correct. The three types, right?
Yeah.
So API is an interface definition. API is a web service. API is a proxy. So this is again more of a broader classification, how you want to and why you want to build an API. So each one has got a different purpose. Each one has its own unique and discrete way of defining things, and the purpose of its end use of an API. So yeah, just go through these slides even very briefly, Mahesh,
Mm-hmm.
because again we have team members who are not very experienced, and I want them to understand as well.
Okay. Yeah, we'll go to key points of APIs. So API is nothing but it provides the information for how to communicate with the software component in specified manner that operation what to call. It's acts like a verb, then get, put, and all. Then inputs what to send with the call, and output what will we get from that call, and its underlying data types. So actually, it's providing the service which we can communicate with end system with the help of APIs. Then let's go for web service. Web service is a method to communication uh, that allows to software system to access data over the internet. That means when we connect to different systems or software, then there has to be some uniqueness with that software. If not, then we can expose those systems as a web service, and which will has some rules and regulation, and with the help of that rules and regulation we can expose that service. uh, with the help of that web service they can interact our actual data. So basically there are two types of web services. One is soap service, which is traditional one and which is more complex one, because its communication rules are defined in XML based WSDL. WSDL is a web service description language which has more information about how what are the inputs parameter that needs to be passed, and what are the security layers that this service expecting, that like which is in header, like authentication authorization one. Then another type is RESTful web service.
Just to
Yeah.
stop you there, yeah, beyond the definitions and more visibility into how this web services is expecting, I think one of the important thing in a SOAP service, it's worth to mention that it is a well-defined form. And what you mean by well-defined is basically you have a scheme and definition predefined around this. So the tolerance for making errors is pretty less, or not making error. The tolerance for the consumer to pass things outside of this definition is not in scope. So it is not loosely defined, unlike which is the case in RESTful services, but it is well defined. And the schema, the it's definition defined in the form of an XSD behind it, but the schema is important in a SOAP-based service.
Plus, I mean, just wanted to add here, like, it's an agreement or basically a contractual document. Like when we talk about SOAP, like what exactly we need to pass, where exactly we need to pass. So all those details around those endpoints is listed there in the visual document.
Yeah, it's well defined, right?
Mm-hmm.
So it has got rules, and it is most suited for an enterprise level scenario. But what it loses with that is flexibility. And this is where RESTful services, especially with the introduction of social media and similar applications, where they needed very high flexibility on one side, and second, they didn't want the overhead of a well-defined structure, because SOAP services does come with an overhead because of the SOAP envelope in it.
Mm-hmm.
The envelope contains certain structures in it. So when you have, let's say, 50 different operations that you want to do, or 50 or even 100 or 200, the WSDL becomes pretty heavy. So loading that WSDL in memory, dealing with it, handling the schemas around it, all of that becomes a very memory consumed operation, which is not really well fitted for a social media kind of application where the volumes are low and it's more like a tweet kind of scenario, right? Or a messaging platform. So for a messaging platform, SOAP is not well suited. But in an ERP scenario or in a scenario like where you have all your endpoints well defined. When I say endpoints, I'm talking about the data interfaces well defined. Your objects are predefined. That is not going to change for the next 2 years with the version. So there, those ERPs have more control how they release, how they maintain these APIs, and this will communicate to the end user who's going to consume. When I say end user, I'm talking about consumer of these services, a better understanding of what need to pass, how you need to pass, what are the restrictions, how do you validate your input data, which is XML based, and things like that. And also keep in mind that XML parser eventually that the engines would use both at the caller side and at the provider side, those are also more memory hungry parsers. Some of you may know that, a REST based parser versus no, not REST, sorry, a JSON parser versus an XML parser. It is definitely more demanding in a DOM structure. You know that it uses a DOM structure when you want to parse XML. The DOM parsers are not very efficient when it comes to high volume processing and memory and its memory structures behind it. So this is where the REST services, which is becoming more and more popular, it is not the best way of defining, it's not the best way of controlling, but it serves the purpose. And it gives you enormous flexibility with the JSON structure and REST-based protocol. Yeah, so that's how I'm looking at it.
Okay. So second type is RESTful web service. It uses existing or HTTP communication protocol, and HTTP request method indicates which operation should be performed. Then there are various types of operations that we can perform, like get, post, put, delete, patch. So with the help of that
By the
operation,
way, guys, Mahesh, just want both SOAP and REST uses the underlying protocol is HTTP.
HTTP, yeah.
So just wanted to
So
read.
yeah, SOAP request sent as a body of HTTP post, and REST may have all these uh, details in URI. That
It may have in
yeah,
URI, it may have in header, it may have in body,
yeah.
depending on the type of call.
Mm-hmm.
But in the REST, it uses pure HTTP protocol, nothing else. So it's it's here, right here. Yeah, yeah. Go ahead.
So as I mentioned earlier, that HTTP request method indicates which operation should be performed on the object identified by URL. Then these are the operations that we can perform, and data and resources are represented using URIs. In SOAP web service, this operation are considered as a body, but in REST, this can be represented using URIs. Then these are the sample REST web service calls that we are calling get method with companies. Then second example, we are filtering those all companies data with only country France. Then third example, we are querying only third company. Then post companies with sample JSON or XML in HTTP body. Then company slash 3, we are deleting this number 3 company. The same like put, we can pass the actual data which needs to be created or updated. Then these are the sample API that we have called, and it's giving the records flights which is in SFO destination. So they have also provided the walkthrough that we can go and search or do practice on those APIs.
Mahesh,
Yeah,
we need to be cognizant about the time. I think it's almost an
yeah,
hour.
it's already covered almost all the topics, but it will give only 5 to 10 minutes.
Okay. I mean, if everybody's fine, I'm okay with that. But we just need to be cognizant of the time.
Yeah.
Go ahead.
I'm fine. I don't have any. I'm fine.
Yeah, I know you, but the team in India, some of the people they have to travel far. So I
Oh,
just
okay.
I know that on this side we are fine. Yeah.
Yeah.
Thanks. But Mahesh, I see a slight concern from my side. The content here is very good. I don't want you to skip a lot. If we have to take time, as I said, we are not in a rush to finish anything here. Okay. So make sure that you go through the slides, spend time, especially on the initial. You're laying a foundation here, and let that foundation be proper for every person. As I said, it might be repeating for me, but I should just keep quiet and listen, right? Because somebody else is learning. So I'm okay in slowing down. I'm not okay in going fast. What do you think, Vishal? Vishal is sleeping.
No, I'm here only. I was on mute.
Okay. Yeah, because I do not know. Again, at the end of this call, I need 5 more minutes because I want the team participants to chime in. Because I do not know what levels they are, and I don't want if they lose this as we move forward, they will be lost.
Yeah, I mean, sir, we will be discussing all those type. So Mahesh, make sure that every topic which is in the document is to be covered. Like if the things are clear, we'll go briefly. If the things are like which is tricky, we'll go in detail.
Yeah, and again, this is we are laying a foundation. Let's lay it proper. Once we all understand, maybe the pace can increase. But I don't want the pace to be very fast now. That's my point, right?
Okay. So this is the producing discoverable and consumable asset is a key of successful application network. That means we'll create some artifacts and which will deploy it in our portal, that in developer can discover that artifacts and give the feedback and usage metric that will use for reusable assets. That C4E team will evaluate those feedbacks and will create reusable assets out of it, and it will give more faster than previous. So in production wise, central IT and LOB IT takes in picture. Then in consumption, the actual developers and LOB IT team will be using those artifacts. Designing for API success. So create APIs that developer can find and what to use and share with others. Designing API for the business use case, which will fulfill the end user requirements. And actually what happens in a API lifecycle will be just only designing those APIs which is not modeled as a backend service. They are exposed as a design APIs, and that are give access to our developers. Then developer will go through those APIs, will discover some new requirements, and once we finalize that requirements and this mock APIs is ready to for development, then this will API comes under development phase. So actually it's a API design approach. That means we'll first design this API, will mock it, and will discoverable to our actual developers. This is the designing API success that MuleSoft called. It will not directly model as a backend service and give the actual result of user. First, developer will assess that API. Will that API is giving a proper output? If yes, then they can go for development phase, or it's a continuous process that this is the designing APIs. So it's a like iteratively process that we are getting feedback from developer, and we'll make modification of on that API, and then we'll again pass this API to developer to test. Once the actual designing is completed, then we are start building the implementation of that API. So this is the actual API development lifecycle. We'll go deeper in each module. Like designing, simulating, feedback, and validate. With these phases, we'll get the API spec, which is in RAML. And once we finalize that RAML, we can build that implementation part with the help of AnyPoint Studio, and we can test that with the help of Runtime Manager. Once we test that application, that we can deploy it on our Cloud Hub or on-premise server, which will be used to service with APIs like versioning, securing, deploying, and register, monitor, analyze, troubleshoot, scale, and respond, which is a continuous process. So once new requirements will be added, then new version will be created with the help of new requirement. So this is the main API development cycle that we need to follow. Each module has its own platform to perform that operation. So we'll go in detail in next session what actually design phase, simulate phase, and all of the phases. So that's the complete our first session, application network.
Okay, thank you.
Thank you. So I want to like highlight one points that's
Sure.
when I search on Google, then I found one white paper document on application network, so which is also useful for to know what is actually application network and how it works. So
Okay.
I'll share this document with you, so you will
Okay.
get more understanding.
So here is some logistics. We need to share this on a URL, I mean, in a Dropbox or somewhere, or even in our Microsoft portal,
Mhm.
and then provide the link. And the location should have clear identification of session. So this is today's is session 1. Also maybe put the date. This is 14 Jan. And then all the content for today should go into that folder, or however you want to position it. Basically, you need to have clear differentiation of if I want to look for something, I need to go to that particular day, this session, this was covered, and this is where it's available. For now, keep it like that, right?
Okay, yeah.